Good day, YouTube community. This is Professor Friday from Macomb Community College. A very happy MLK Day to everybody watching today. Let's see. Good start to the day for me. Got to spend an hour on the treadmill at the gym, watch the President's inauguration, or at least most of it. So, all in all, good day today. So we've had a request for a problem that is similar to problem number 6 from the 5-3 homework from WebAssign. So the problem stated that if you have a rational function, if f of x is equal to x plus 9 over x plus 3, where x is greater than negative 3, to find the derivative the derivative of the inverse function evaluated at 2. For the most part, rational functions where you have a linear numerator and a linear denominator are one-to-one functions, and so they have inverses. The inverse. Now, in order to do that, though, we're going to recall one of the properties from class for finding derivatives of inverse functions. Oh, spelling is hard. Sorry. Property of inverses. If the point AB is on the graph of y equals f of x, then the derivative of the inverse function evaluated at x equals b is the reciprocal of the value of the derivative of the original function evaluated at x equals a. We know that for the inverse function, if AB is on the graph of y equals f of x, then BA would be on the graph of the inverse. So the property that we proved in class is this right here, that the derivative of the inverse function evaluated at the y value of the given point is the same as the reciprocal of the derivative of the original function evaluated at the original x value. So we've got a couple things. In our function we've got f of x is equal to x plus 9 over x plus 3. We're also asked to find the derivative evaluated at the inverse function at 2, which means that the point on the inverse function is 2 comma something. Now, based on what we know about inverse functions, the x value for the inverse function is the y value for the original function. So the point on f of x is going to be something comma 2. Again, the 2 that was given in the original problem would be a y value for the original function. So first thing I'd like to do is figure out what is the x value for the original function. Let's move that paper down a little bit. So what we're going to do is set f of x equal to 2 to figure out the associated x value. X plus 9 over x plus 3 is equal to 2. We're going to solve that. Now the technique for solving this, generally what I tell my classes is that fractions are horrible, evil things that are worthy of being destroyed. So what we're going to do is destroy us some fractions. To destroy a fraction, we multiply both sides by the associated denominator. That would be our x plus 3. We'll do this in fancy red because we're canceling stuff out. So left-hand side of the equation becomes x plus 9. Right-hand side of the equation becomes 2 times the quantity, x plus 3. The resulting equation is linear. We've been solving those since we were in mathematical diapers. So, what we're going to do is distribute over on the right-hand side. Take this down to x plus 9 is equal to 2x plus 6. Now to get x on one side of the equation, we're going to subtract x. Now my x's are going to be on the right-hand side, so I want my constants to be on the other side. Got some more cancelization taking place. Cancel, 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 cancel. Put it all together. Got 9 minus 6 is equal to 3. 2x minus x is equal to x. So the associated x value is going to be x equals 3. What I'm going to do is put that back up here. This is what we were originally trying to find. We'll put that in red since it's a new piece of information. So the point on f of x is 3, 2. The point on f inverse of x will be 2, 3. Now, based on our property that was listed a moment ago, if we want the derivative of the inverse function evaluated at 2, this will be 1 over the value of the derivative of f at our value that we just found. And the value that we just found was x equals 3. Now that we know this much information, what we're going to do is take our function f of x, take a derivative, plug in x equals 3, and then find the reciprocal of that, and we will have the derivative that we wanted. In order to do that, though, I need a little more space, so I'm going to flip over the piece of paper, but I'm going to recopy down this original function, x plus 9 over x plus 3. So we got f of x is equal to x plus 9 over x plus 3. To take the derivative of this, we'll need some quotient rule. Quotient rule says low d high less high d low over the square of what's below. Or as I tell my Calc 1 class, I actually do this with my hands. Low d high less high d low over the square of what's below. I really hope the audio and the video sync up when I actually upload this to YouTube, otherwise that's going to look really awkward. Regardless, we now have f prime of x is equal to, we got x plus 3 times derivative of x plus 9, throw that at a Calc 1 student, they'll probably be able to tell you, minus x plus 9 times derivative of x plus 3, again, throw that to a Calc 1 student and they'll tell you, over x plus 3 quantity squared. Now after we distribute the minus sign and do a little bit of canceling, I'm going to assume that you can do the algebra with me. X minus x and a 3 minus 9. Up top, we're going to have minus 6 over x plus 3 quantity squared. Now with our derivative, we said that the x value associated with this was x equals 3. Wait, I think it was x equals 3. I'm going to flip back and make sure. Yeah, the value of x that we had associated with this was x equals 3. So I'm going to go ahead and plug in x equals 3 and see what the value of the derivative is. So we'll do f prime of 3 is equal to, this will be negative 6 over 3 plus 3, quantity squared. Then we go order of operations, parentheses first, then exponents. This will be negative 6 over 36, and then we reduce. So we get that the value of the derivative of the original function evaluated at 3 is equal to negative 1/6. So I'm going to grab this, I'm going to flip back over to the other side where we needed this piece of information. Value of this derivative that we just found was equal to negative 1/6. Now when we're dividing by a fraction, we can say take the reciprocal of whatever's in the denominator, and reciprocal of negative 1/6 would be negative 6. We can tell it's a final answer because it's in a box. There's a little smiley face next to it. I hope this was helpful, and until next time, enjoy your day.